Okay, let's say chapter 12 test. You mentioned problem 20, so let's say what's here. The following figures show the specification for cross section for parabolic reflector. Determine the focal length and the focal ratio of the reflector. Right?
Mm.
Yeah, for the ratio, I forget its distance to f or anyway. I mean, when if here they didn't show the focus. Anyway, we'll find this. Normally we call it p or absolute value of p, right?
Mm.
Another we just call it's like the length. Yeah.
Mhm.
Anyway, we can go there review a little bit. How about let me copy this? Oh, can I copy this? Oh, yeah, I can. Then let's go to chapter 12. Parabola. Okay, let's quickly have a review. I suppose there is an example on this. Yeah, like here. Yeah, the focal ratio is P over D, right?
Mm.
Mm. Then let's go back. Yeah, but how they call it? Oh, just say focal ratio. Mm, focal ratio equal to P over D. Okay, the D here is what's the D here?
E 是那种 it's 5.
No, not E. D. D
Oh,
servos means distance.
yeah, it's 16.
The double of 16. You
Mhm.
say it again. D means from most left to most right, right?
Mhm.
So, but just now the 16 just half of it, right? So anyway,
Mhm.
D is 2 times 16. Then we just need the P, right?
Mhm.
The equation for this can write as y equal to 4p over x squared because the vertex just at the origin, right?
Mhm.
And it's open up. Then here it's like we know a point on this graph. When
Mhm.
x is 16, y is 5, right?
Mhm.
Yeah, then we use it. Y is 5, x is 16. So 16 times 16, 4p. Then we can get p equal to 5. Anyway, 5, right?
Mhm.
Mm, yeah, so this unit is meter. So suppose the focus is at about, let me say this is about 12, close to 13. So the focus like about here, right?
Mhm.
Anyway, then we can get the P over D equal to, so this is 64 over 5. then we get it's like 2/5, right?
Mm-hmm.
Or 0.4. Yeah, this is the focal ratio. So not quite hard.
Mm-hmm.
Use the general form for parabola. Then make use of this point on it to get P.
Mm-hmm.
Okay. Any more problems?
Not really. Others are
Not
like
really. Okay.
average
Yeah, then we
problems.
save some time. Last time we finished section 13.1. Yeah, as today is the last class for this course. So we'll just pick some core contents for today's 2 hour. The remainder theorem and the factor theorem. Okay, let's go here. Yeah, we'll go through section 13.2 and 13.3.
Mm-hmm.
Then go to chapter 14. The remainder theorem and the factor theorem. Okay, let's just go to this theorem directly. When a polynomial is divided by x minus r, the remainder is f of r. Hmm. Yeah, the reason is we can write it as, for example, f of x divide x minus r, right? Then it's equal to like what we call quotient of x plus the remainder, right?
Mm-hmm.
Remainder of x. Oh no, let me say remainder. Suppose here we should write x minus r. Then anyway, write in another form. So x minus r, q of x plus r of x, right?
Mm-hmm.
So when we let x equal to r, f of r equal to, as x equal to r, this go to 0. This go to 0 plus r. So then f of r just equal to this remainder, right?
Mm-hmm.
Mm. But for the remainder, you can do a division to get it. Anyway, let's see here, using remainder theorem to evaluate f of 3. If is x minus 3 is a factor of this, then it's depend on if f of 3 equal to 0, then x minus 3 is a factor of this, right?
Mm-hmm.
Mm. So let's say they use the division, synthetic division to get the remainder. As it's 6, so this is not a factor, right?
Mm-hmm.
Check for a factor. Okay, another theorem, fact theorem. Let f of x be a polynomial. If f of r equals 0, then x minus r is a factor, right?
Mm-hmm.
Okay. Yeah, we'll pass this rescript. We already know two root. Then, yeah, we can do division to find, then keep going. Yeah, that means that we degraded. Let's degrade from 4, degrade to degree equal to 2. Then it's a quadratic. We can handle it, right?
Mm-hmm.
Okay, let's go to some exercise. Yeah, how about you pick a problem from this page? Yeah, ideally pick a odd number problem.
I only do 23.
23, okay. Is one for your favorite number?
No,
Mm,
I just
mm.
choose a random.
Yeah, in NBA or in basketball court, 23 normally you related to Mike Jordan, right?
Oh,
Or maybe LeBron James.
oh, okay.
Okay, anyway, let's say, what did you say here? 23. Oh, come on. Use the remainder theorem to evaluate for the given value of x. It means just go to find the f of
Oh,
this, right?
oh, it is. Okay.
Oh yeah, no, here we can go to find the result. Let's say, then this just means 2. This means 3, 2 square root. Oh no, negative, right?
Mm-hmm.
Then minus 4. So together it's -2, -3, 2 square root, right?
Mm-hmm.
Uh, but does this also mean we can do that division to get the same remainder? I suppose it means this, right?
Oh, okay.
So let's say if x is this, x minus, mm, x minus, yeah. Then if we do static deviation, suppose it means this is, yeah, let me just write here. Then this is 1, 3, -4, right?
Mm-hmm.
Then here is 1, so negative, add together is 3 minus 2 radical. Then multiply is -3 2 square root, then plus 2. Then finally get this. That means the same result, right?
Mm-hmm.
Okay. Then let me choose one for you. What's here? One or more roots. Check that the given number really are roots. Then solve each equation using. Anyway, later you solve equation. Right?
Mm-hmm.
We'll choose one. It's let me say. How about 31?
Okay.
Yeah, 31. Yeah, if you want, you can just write on screen directly.
Mm-hmm.
Neil went to Disneyland.
Mm-hmm. Yeah, I saw it.
Yeah. So
Wait, let
first,
me.
then later you check if -2 is really the root, right?
Yeah, it is a root. And
Yeah,
you can factor this.
just you using it replace x to say if left side equal to right side, right?
Mm-hmm.
Okay. Mm. Okay, you can go ahead. Let me check it. So it's 3 times -2 cubed minus 5 -2 square minus mass 4 12. Yeah, equal to 0. So true. Why you have this?
You're supposed to check if it's a root.
Mm.
Oh, I thought you're supposed to
But
like
do you mean
simplify.
you use this divide
Yeah, yeah, I
x
do get.
plus 2, then you get this? Do you mean this?
Yeah, I do get 0.
Then you need to keep going solve it, right?
Okay. Yeah,
Because we need to find all the roots.
then x also equals to 3 and 2 over 3.
Okay. Okay, good. Then let's go next section. Fundamental theorem of algebra. Yeah, we'll go to this directly. Every polynomial equation of the form has at least one root within the complex number system. This root may be a real number. Then it means maybe it's not. Also, it means maybe it's not a real number, right? That means no real roots. Yeah, when we solve quadratic equation, we already meet the case. There is no any real solutions, right? So here, talk about it among complex number system. This is called the fundamental theorem of algebra. Yeah, I suppose there are more theorems. The linear factor can be expressed as a product of n linear factor. Yeah, we'll not go through the proof. Then keep going. A corollary to the fundamental theorem. Every polynomial equal of degree n greater than or equal to 1 has exact n roots. Where a root of multiplicity k is counted k times. So what's this mean? For example, if equation is x minus 1 square equal to 0, right? Then we know there is just like one solution, x equal to 1. But this is a quadratic. Per this theorem here, its degree is n, then suppose there is n roots, right? But we just get 1. Then we have to count this as twice. This we call multiplicity. That means that if x minus 1 square, then this called the multiplicity. You know this mean?
So is it like if there's like if it's like squared or like it has like a integer, positive integer exponent, there will be like a solution would be counted n times. Does that?
Yeah. Count k times, or you mentioned n times.
Yeah, so how do we express it? We just write the same solution for like n times, or
yeah. So we can have some, for example, for quadratic, we know if it's this way, then there are two roots, two different roots, right? Then you just think this graph move up. For example, when move here, still has 2, but this 2 closer, right? Then keep go up. Then we suppose at one moment, this just has 1 point touch with x-axis, right? So it's just like this 2 point go and combine into 1, right? So you can still think it's 2, but they are the same.
Oh,
So
okay.
that's the reason we want to count it twice. Yeah, only in this way we can say for polynomial n degree, then it has exact n roots,
Mm-hmm.
include real roots and complex roots.
Mm-hmm.
Yeah. Finding f of a given roots and yeah, so just see here. Hold. The root 3. Oh, come on. The multiplicity is 2. Negative 2, just one time. 0 count as 2 times. So when you write it, it's this. Right?
Mm-hmm.
You say 3x minus 3 twice. That means it's x minus 3. Another x minus 3. Then we write it as x minus 3 squared. Right?
Mm-hmm.
So this represents the multiplicity.
Mm-hmm.
Using the linear factors. Okay, we'll pass this. It's just so quadratic equation. There are two roots between roots and coefficient, and the sum of these two roots is negative b. The product is c, right?
Mm-hmm.
Yeah, we also make use of this to do factorize. So by the way, maybe we can say this a little bit.
Yeah, this is like
Yeah,
it's like the
negative.
formula for
Yeah.
two-bit equations. Yeah.
Mm. You say, for example, for here. Oh, come on. You can think it's three variables, three equations, right?
Mm-hmm.
Then suppose you can solve it.
Mm-hmm.
But it's not a linear system of equations. So,
Mm-hmm.
sometimes maybe it's hard. Uh, Anyway, now let's do some exercise. How about the problem 7? Let me say you are given a current function. However, the fundamental theorem doesn't tell you whether the equation has any real number roots. Use a graph to determine. You are not being asked to solve the equation. So you just use like a decimals to draw it, right?
Mm-hmm.
Yeah. If you, for example, for problem 7, you just take this as a function, right?
Mm-hmm.
Yeah, to draw it. If the graph of the function intersect with x-axis, then it means there is a real solution, right?
Cool.
Uh, okay. yeah, 20s. Find a polynomial with leading coefficient 1. Has the given roots and no others. If the degree is the same, expressed in factor form. Okay, let's choose one. How about the 23?
Okay.
So what's the degree for problem 23?
6. You are muted.
Oh, yeah. So you mean what's the degree here?
3. I mean 6.
6. Okay, so just now shows if degree not 7 or more, we should write as this, right? This we call standard form. Okay, anyway. Then how about let's do this. Yeah, I'll make a whiteboard. Okay. Do you have idea how to write the function? Whose
No.
roots are this? You mean you have or you don't have?
Maybe.
Yeah, you can try.
Wait, okay, let me try. Wait, I seem to have some idea.
Pardon me?
Wait, I have some idea. Maybe.
You have some idea.
Yeah, I'm trying.
Are you writing on paper?
Yeah.
Oh,
Uh,
so you guys are still not feel comfortable right on screen directly.
I got part of it.
Oh, maybe it's because your equipment.
Yeah.
Oh, you already do. Let me say. Oh, okay. So you skip some steps, right?
And it could be like more
Okay. You can
or
stop here. So first we write f of x equal to root of 3 square root. So it's like x minus 3 radical. Here multiplicity is 2, so it means square. Then similar than x plus square. Then x minus 4i. Then x minus 4i. Right?
Mm-hmm.
Yeah, anyway, from this, you get, you say maybe there's some mistake,
Oh.
right?
Mm-hmm.
What, how you can get from this? From this?
So you get x squared and then okay, and then
Yeah,
like they cancel out the 4
mm,
4i, and then the 4i multiply itself, like the two 4i's,
mm,
we get wait, let me see. Wait, it's actually positive 16, yeah.
yeah, here should go to
Yeah, it
positive,
should be
right?
positive, yeah.
Then let's talk about here. Excuse me. Yeah, before we take square, we can do this first. This minus this. Why? Because we can make use of the formula difference of squares, right?
Mm-hmm.
Anyway, here go to x square minus square of 3 radical, so just 3. Then take square. Let's say if it's x fourth power minus 6x squared. Yeah, so this is correct. The only thing wrong is x squared plus instead of minus, right?
Mm-hmm.
Yeah, then you keep do the multiplication to write it as standard form, right?
Mm-hmm. Yeah.
Okay, then we'll stop here for this section. Let me check anything more. Rational and irrational roots. Oh, we'll also go to uh, section 4 because there is more important theorem. The rational root theorem. All coefficients are integer. Let P over Q are rational number, where P and Q have no common factor other than this. If P over Q is a root of equation, then P is a factor of A0 and Q is a factor of AN, right?
Mm-hmm.
Yeah. Yeah, that being said, these rational roots, yeah, here called rational roots, tightly related to leading coefficient and the constant, right?
Mm-hmm.
Mm. Yeah, so this is an important theorem in order to find the rational roots. When you find some roots, you can degrade the polynomial, right?
Mm-hmm.
So say the A0 is -4. So its factor is positive -1, positive -2, positive -4. Factor of A3 means the leading coefficient is 2. So its factor is positive -1, positive -2. So make the P over Q. So you get so many options, right?
Mm-hmm.
So you just go to check who who is a root. Of course, you starting from the easy one, right?
Mm-hmm.
Yeah, for example, positive, negative 1. Then maybe positive, negative 2 is are either than positive, negative half, right?
Mm-hmm.
Yeah, anyway, you just go to uh, try and check. Okay, I think that's the important theorem we want to go through. We don't want to go through more to save
Okay.
time. Mm. Yeah, let's quickly the no code. Then we can have one for practice. Let me see. We'll find someone not quite hard. 修在一起. We wanna solve, find the rest of each equation, then solve. Okay. Yeah, let's just try 17. It's the
And
most simple one I can find.
yeah, we don't need to deal with
Uh,
some.
so could you list the possible rational solution?
Okay.
Did you meet with this before?
Yeah.
Oh, in which course? Algebra 2 or
I've seen algebra 2. I've learned a
oh,
lot of like more
oh,
complicated things in algebra
okay.
2, like conic sections. I don't know why it's
So let me
included in
say,
this. And also, this should be positive and negative.
mm. Yeah, so here is quite simple. For negative 3, the factor is positive, negative 1, and positive, negative 3. For this, they just positive, negative 1, right?
Yeah.
Mm. So anyway, if even symbol just means positive, negative 1, positive, negative 3, right?
Yep.
Now let's try.
Okay.
Of course, we're starting from here. How about let's try 1 first. If 1, yeah, 1 is a solution, right?
Mm-hmm.
1 is a solution. Then you can use this. Divide x minus 1. Let it go to uh, the, the quotient will be a quadratic formula. Oh no, quadratic polynomial, right?
Mm-hmm.
Yeah, then we can solve up. Okay, that's it. Yeah, this time we'll really go to last chapter. More topical. Mathematical induction. Binomial theorem. Maybe we'll just go through this too. Then if we have time, jump to 14.6.
Okay.
Yeah, anyway, let's see. Induction, conjecture, mathematical induction. For each natural number k, if pk is true, then pk plus 1 is true. Then means all true, right?
Mm-hmm.
Then this statement will be true. Mm. Okay, they just tell us this. Okay, let's do some exercise. True for all natural number. So want to then anything else. Complete the following table. Yeah, how about let's just try, maybe we can find another one. How about we do this?
Okay.
33. If r is not 1, show that this is true for all natural number n. Yeah, how we should do it?
I'm not sure.
Mm.
I don't really have any idea.
Yeah, okay. So I suppose it means you try if n equal to 1 or n equal to 2. Anyway, this means if n is 1. So what n here means? I suppose it means how many terms, right?
Yeah.
Uh, yeah, here n should greater for all natural number n. Yeah, n can be 1. If n is 1, so n minus 1 just 0. Then it's just means there is just one term. If we call this is S, and it's like sum of n terms, right? N
Mm-hmm.
is 1, S1 just equal to 1. Is this equal to, you say, R0? Because n is, oh sorry, n is 1, n is 1, right? Minus 1, R minus 1. So you say it's true, right?
Mm-hmm.
Yeah, even
Oh.
you can check n equal to 2. If n equal to 2, s n equal to what? No. Now n is 2, so we call it s2.
Mm-hmm.
S2 equal to what?
2.
No, see here.
Oh.
When n is 2, 2 minus 1 is 1. Means its
That's
last term is r 1's power, uh, which is just r, right? So it's
uh
1 plus r. We'll say if it's equal or not. So n is 2 minus 1, r minus 1. So this just equal to r plus 1, right?
Mm-hmm.
So it means they are equal. That being said, this formula is true, or this conclusion, this statement is true, right? So let me write here, true, true. Now you suppose if Sn equal to 1 plus r squared equal to Rn minus 1, r minus 1 is true, then if Sn plus 1 is equal to this is true or not, right?
Mm-hmm.
Then we'll say Sn plus 1 equal to 1 plus r plus till Rn minus 1. Then plus, yeah, because r is n plus 1, so this n go to n plus 1 minus 1, so it's just Rn's power, right?
Mm-hmm.
Yeah. And don't forget this is just this. We already say this is true, right? It's our hypothesis, means this is true. So we can say this equal to r n's power minus 1, r minus 1, plus this. So we let this go to r minus 1, then r n multiply n minus 1, right? Yeah, so let's go here. R minus 1. Hold. Oh, sorry, this is R. R minus 1, right? So, let me rewrite it. Sorry. So here is R minus 1. Then we have R minus 1, Rn minus 1 plus Rn plus 1 minus Rn, right? Then this go to R minus 1, Rn plus 1 minus 1, which is just what we call S. Yeah, anyway, that means that this statement is true, right? Mm. Then finally, the topic of this section, mathematical induction. Means by this kind of induction, we say this statement is true, right? Yeah, then please have a screenshot.
Okay.
So are you done?
Wait, almost.
Not yet. Okay.
Okay, I'm done.
Okay. Yeah, then we'll go to next section, binomial theorem. Have you met with this before?
I've heard about it.
You hear about this?
Mm-hmm.
But not really know this theorem, its content, right?
Yeah.
Yeah, it's used to do this. For example, let me show you. For this, for example, even I let it a little bit of communicate. Hold. So let me have a whiteboard.
Isn't it used to like to solve like a
Yeah. For example, if 2x minus 3y, if it's a square, suppose you can use the formula, right? But how about if it's this? Do you think you can expand it?
I mean, if you take time, you could, but it's
You
just
can,
very
right?
complicated. Yeah.
Yeah, but if it's this, then it's hard, right?
Yeah, it's very hard.
Even it's impossible. No, of course it's possible if take time,
Yeah,
but
it's
it's
very
really,
complex.
really time consuming, right?
Yeah.
Yeah, sometimes we just want to know one term after expand. Suppose there are 34 terms, right? Yeah, the leading term suppose is x 33 degree. Then x, next term is, of course, there is coefficient, then 32. Here you go to x is 0 degree. So there are 34 terms, right? So maybe we want to find, for example, one is x. If, for example, x is 20, 20's power. Then y suppose is 13 power. Anyway, the sum of the equivalent should equal to 33. Then we want to find the coefficient, right? So that the binomial theorem help us to find this coefficient quickly,
Mm-hmm.
or let it go to possible. Mm. Okay, so let's go to this theorem. Binomial theorem. Mm. Property summary. There are n plus 1 term. Means when you expand it. Yeah, even here mentioned in ancient China, uh, they also mention the Pascal triangle, right?
Mm-hmm.
Mm. Named by, as figure 1 indicate, the Pascal triangle was known to China mathematical centers earlier. Mm. Yeah, proud of it. So you can using the coefficient to make a triangle, right?
Mm-hmm.
Yeah, which also help you to remember it. Remember this coefficient. So the rule is like this. Yeah, you can think maybe you can draw it as a circle, then it's yeah, for each circle it's equal to the sum of the top terms, right?
Mm-hmm.
Mm. Yeah, for example, for this 10, you can think it's from 4, 8, 6.
Oh, okay.
Uh,
Mm-hmm.
Now let's say if we can draw this Pascal triangle by ourselves. Let's try. Oh, where is it? So you can think, how about let's use x plus y. If it's zero's power, so it's just 1, right?
Mm-hmm.
Then if x plus y 1's power, so it's 1. Yeah, as I mentioned, I would like use circle 1, 1, right?
Mm-hmm.
Then can you draw this third row? Third row.
Let me try. Mm-hmm.
Yeah. Then let's have. So this we are still familiar with it, right?
Mm-hmm.
But for this, frankly speaking, we are not so familiar. Then, okay, you'd better draw it big. Then when we go here, let me use a different color for each layer. So draw one here, one here, one here, one here, right?
Mm-hmm.
Then, of course, for both ends, it's 1. Then for here, 1 plus 2, so get 3. 2 plus 1, also get 3, right?
Mm-hmm.
So how about you draw next layer? And it's the last layer we wanna try.
Okay.
Yeah, so let me draw it for you. All right, by the way, it's for this. Okay, even let me quickly draw one more layer. Black. So 1, 1, 5, 10, 10, 5, 1. All right. By the way, they are like symmetry, right? Left,
Yeah.
right symmetry. Correct?
Mm-hmm.
Oh, hold a minute. So suppose, yeah, you say symmetry, symmetry, symmetry. Anyway, it's a infinite triangle, digital triangle. Then if you make use of a Pascal triangle, can you do this? Let me ask you. Hold. Yeah, we'll do this. We will not go to the difficult one. Just try this. But if expression is, for example, as I mentioned, is 2x minus 3y fourth power. Now can you expand it?
Well, how did you expand it?
Yeah. Yeah. Okay, so let me tell you. You can think it's 2x is like the a here. Then negative 3y is like the b here, right?
Mm-hmm.
Yeah. Then per the, let me change color. Per the expression here. What this one means? It means the leading coefficient. That being said, 1 of 2x power, fourth power, right?
Mm-hmm.
Then for the second one, coefficient is 4. Now it's go to 2x cube times b is negative 3y. Yeah, then keep going, it's 6 times 2x squared. Then negative 3y also square. Yeah, remember what I mentioned? The exponent, the sum of the exponent always equal to the degree 4, right?
Mm-hmm.
Yeah, we already finished this. Then keep going plus 4. Now 2x just 1's power. Then b is negative 3y is cube. Then last negative 3y fourth power, right?
Mm-hmm.
Then it's expand. You can do some simplify. Okay, I would suggest you can screenshot this.
Okay. Okay, I'm done.
Definition factor.
One.
Yeah, suppose you have an idea about the factor, right?
Mm-hmm.
Yeah. Then we'll pass this. Now
Wait.
definition. Oh,
Yeah, yeah. What does that thing mean? Like the thing underneath, like wait, it's a little bit more underneath.
Which one?
Like this thing with N and K, like
Where?
with N at the top. It's like a little bit. It's
Uh,
no, it's wait, go down.
go down.
Yeah, it's like the thing with N
Oh,
and K.
this, right?
Yeah. That's.
Yeah, it's an idea from combination. Here you read choose n choose k. The notation is read as n choose k. It can be shown. Let me see. The second notation that we introduced. Yeah, so means above talk about the factor. Then this is another notation, right?
Mm-hmm.
This notation read n choose k because it can be shown that nk is equal to the number of different subset of k element from a set of n element. Okay, it's just like idea. You choose k element from n.
Mm-hmm.
Yeah, for example, in your class there is 50 guys. Then you choose 4 from them, from this 50. Then you let these 4 guys go for vacation, right? It means
Mm-hmm.
choose 4 from 50. Like n is the 50, is a
Mm-hmm.
set. K is a
Mm-hmm.
subset of it,
Oh,
right?
okay. Yeah.
Mm. Okay, now let's talk about this. Binomial coefficient. Let n and k be non-negative integer. Yeah, is defined as n factor over product of k factor and n minus k factor, right?
Mm.
So do you have idea why it's the expression is in this way? It's
No,
really from permutation and combination.
I'm not sure.
You are not sure?
Yeah.
So let me just find something. Yeah, even I can send you this book. Okay, say open file location. Yeah, I can put this book in here. Then which section? You see, this is a book for grade 6. It's like at chapter 8 or 9. Let me quickly find it. 9. Yeah, it's about probability. Okay, here show like factor, right?
Mm-hmm.
So let me just show you something. For example, so suppose there is 6 teams. How about just 5 teams? 5 teams. We call A, B, C, D, E. Now you just take the first 3, then rank them like number 1, number 2, number 3. Yeah. Then you think how many different outcome.
Cool.
To make it simple, even we just take 2, number 1 and number 2 from these 5 teams. Then you think how many different outcome. Okay, people will do this. Each of these 5 teams has a chance to be number one, right?
Mm-hmm.
So there are five. Oh, come on. 5 different choice, right?
Mm-hmm.
Yeah, as we already decided number one. Now let's go to decide number two. And don't forget, already one team take the place of number one. Now just 4 teams left, right?
Mm-hmm.
Then you choose one of them. Then you have 4 different options. Then per the counting principle, the total chance is 5 times 4,
Oh,
right? Mm,
okay.
yeah. Yeah, the example is for example, A take the number one. Then for number two, it can be either B, C, D, E, right? Then there is 4 case. Then when B take number one, C take number one, D, E take number one, they each have 4 case. So 5 of 4. That's the reason we have uh total 20 different outcomes, right?
Mm-hmm.
Yeah, that's we call permutation because the order makes sense. Who be the number one? Who be the number two? It's different outcome, right?
Mm-hmm.
Yeah, I mean, for example, one case is A be number one, B number two. Another case is B number one, A number two. They are different, right?
Mm-hmm.
Okay. So that's for permutation. This also explain why we have factor. Just now we just have number one, number two. If we keep going, have number three, number four, number five. Then you can think five, three, or 5, 4, 3, 2, 1. Then finally we have 5 times 4 times 3 times 2 times 1. Then we call this 5 factor, right?
Oh, okay.
Yeah. Okay, you can screenshot this.
Okay.
Now let's take another different case. Let me erase here. Now think about this is 5 different persons. Now we'll choose 2. Let them go to Hawaii for vacation.
Mm-hmm.
So then for this case, never mind you choose A first. Then you choose D, for example. Or you choose D first, then choose A. Now the order doesn't make sense, right?
Mm-hmm.
So that's the reason we call this miscombo. Like you go to have a fast food. You choose a combo, include a burger, a French fry, and a drink, right?
Mm-hmm.
The order doesn't make sense. Now think about how many different outcomes. From 5, you choose 2. Can you imagine how many different outcomes you can get?
Um,
Write them. The simple question, the advantage is we can list all the outcomes, right?
mm-hmm.
Now you try to list the outcome.
Okay, let me try.
Mm.
It's 10.
10?
Yeah.
Which
That's
10? List all of them.
yeah. I think it's like all of them.
Mm.
It's 10.
Could you quickly list them? Frankly
5.
speaking, I don't think there are 10 different outcomes. Yeah, anyway, list all the outcome you think is possible.
Okay.
Okay, you already get 4. Right?
Mhm.
Oh, just now we have. Oh, yeah, it's 10. It's 10. I think it's 4 out of 2 out of 4. Then we just have 6. Yeah, it's 10.
Mhm.
Now let's relate it with the result in last screen. Remember,
Mhm.
just now when it's a permutation, we call P. Yeah, we have different way to write it. 5 means the total. 2 means 2 out of 5. Do permutation. Then it's 5 times 4. Remember, so it's 20, right?
Mhm.
Yeah, then here we have 4 first, then 3, then 2, last 1. So anyway, this total is 10. Excuse me. Anyway, this we call combination. 2 out of 5. So you say it's equal to P 2 out of 5, but you need to divide the 2 factor. Why? Because in permutation, you count AB and BA as different, right?
Mhm.
But in here, for combination AB and BA, they are actually the same, right?
Mhm. Yeah.
So it means in permutation, you double count it. So you need to divide the 2. This 2 is from 2 factor because you just have 2 elements. When they do uh, when they do permutation, they just 2 times 1, right?
Mhm.
Okay, so this is for a case. So more generally, you have uh, let me clear this. Yeah, more generally, for example, if permutation P, if R from, well, let's just use K n. N means the total. N greater than or equal to K, right?
Mhm.
So per the rule, you say you have from n, then n minus 1, then n minus 2. Keep going to which one? Yeah, because you take k, you just have, here is n minus k. Let me say, if so, it's from 0 to 1 to 2 to, so here should be n minus k, but plus 1. That means it's n minus k minus 1, right?
Mhm.
So you say this n you can take as n minus 0. So from 0 to k minus 1, so it's k terms, right?
Mhm.
Mm. Yeah, but in order to make using of the x factor. We need let it keep going to 1, right? So you keep going. Let me use a different counter. Means here you keep going right n minus k, then n minus k minus 1 till go to 2, go to 1, right? Yeah, then for the bottom, you need to divide this. N minus k minus 1 till go to 2, go to 1. So this right as n factor. The bottom is n minus k factor, right? Yeah. Then this is for permutation. If it's a combination, yeah, let me separate. If it's a combination, say n minus k. Remember, we say it's p n minus k, but you should divide the k factor, right? Because you choose k term. This k term do a complete arrangement. There is a k minus k different outcome. But all this just count as 1 because you just, from the opinion of combination, you just choose this k elements, right? So anyway, you need to divide this. Then this equal to n over n minus k. Yeah, it's just here. Then k factor. So that's the formula you can see. Yeah, okay, please screenshot this.
Okay. Okay, I'm done.
Okay. Then if you go to this book, you'll see they'll let you decide the case is permutation or combination. Permutation means the order makes sense, right? Combination means the order don't make sense, don't matter. For example, let's just have one. How many different 5-digit zip code are possible if no digits are repeated? Do you think it's a permutation or combination?
I think it's what's it called? Permutation.
Yeah, because for example, for example, if 1, 2, 3, 4, 5, another is 2, 1, 3, 4, 5. We think they are different zip code, right? So the order makes sense. Anyway, so you can do some exercise here.
Okay.
When you think it's necessary, or you just Google this, you can find a lot of problems. Okay, so let's go back. Oh, come here. Then now, do you think it's kind of familiar, right?
Yeah.
Yeah, I write it as C combo N K. Yeah, some guy write as N is on the top. Never mind. You just know N means the total of the set. K just means a subset. The element of a subset. Now let's go to the theorem. Yeah, just see here. The binomial theorem. When you expand it, there is n plus 1 terms, right? Yeah, its coefficient is, by the way, how they call it? Let me say it again. Called binomial coefficient, right? Anyway, n just take 0, n take 1, till n take n minus 1, till n take n. Yeah, and this always equal to 1, and this also always equal to 1. That's why in the Pascal triangle, for each row or each layer, the two ends always 1, right?
Mm-hmm.
And also we have theorem this equal to this. That means Cn1 always equal to Cn minus 1. So that's the reason we have the left right symmetrical, right?
Mm-hmm.
Mm. Yeah, you can also go to think why this related to combination. For example, let's use a simple example. For example, 2x minus 3y, right?
Mm-hmm.
Yeah, then 2x minus 3y, 2x minus 3y. Yeah, you can think for each term, you just have, for example, for one term, we have 2x, 1 of 2x, then 2 of 2 of negative 3y, right? Then you either choose this, 2x, then for here you have to choose 3y, negative 3y, negative 3y, right?
Mm-hmm.
Mm. Yeah, for another case, maybe you choose negative 3y here, 2x here, then finally you have to have another negative 2 3y, right?
Mm-hmm.
So this is just like a pickup person. Mm. Even you can take, for example, 2x, you just think it's like for each box, there is a black ball, black ball, black ball, and another is purple ball, purple ball, purple ball, right?
Mm-hmm.
Yeah, for a case, you want one black ball, two purple ball, right?
Mm-hmm.
So it's just like you choose, there is three ball. Uh, yeah, how to say this? There is three box. Each has either this ball and this ball. You choose the probability you get one black ball and two purple ball, right?
Mm-hmm.
So this is like uh, yeah. Anyway, this is tightly related with probability. Uh, when we count what's the probability means the total outcomes, total outcome. Then the outcome we are interested. The ratio we call is probability, right?
Mm-hmm.
Yeah, but normally we need to count what's the total outcome. It's a whole number. What's the outcome we are interested? It's another whole number. So that's the reason we have this kind of binomial coefficients. Mm.
Mm-hmm.
So the R term equal to a n minus r plus 1. Another is r minus 1. Mm. So you say the sum is just n, right?
Mm-hmm.
The sum of the equivalent. This, oh, come on. This and this. Yeah, you can go through all this example, but let's do an exercise. carry out the indicated experiment. Oh. Yeah, let's just choose one from here. Yeah, for example, 13. Oh no, 13 is too easy. Let me find I don't want is always one of A, one of B, right? So at least we should do 16. Let's do 16. Or even 17, because here has a negative, right? Yeah, 17. Okay, so you just think A is 1, B is negative 2x, right? Then 6's power. Then we have, yeah, the general formula should be, okay, let me just write one by one. The first is, oh, they just use this, means 6, 0. Means 0 from 6. We know this equal to 1. Then 1, 6's power. Then negative 2x is just 0's power, so we will not write it, right? Then the second one go to 1 out of 6. Then here go to 5th power, then negative 2x, 1's power. Then plus 2 out of 6. Then here go to 1/4 power, negative 2x square, right? How about you write next one? So can you write next one? Means here is 3 out of 6. Then 1, what's the exponent? Negative 2x, what's the exponent? Okay, yeah. So there is a strong rule, right? Yeah, like it's degree decrease. Decrease one when go to next term. Okay, that's it. Then you do some simplify, right?
Yeah.
Oh, by the way, let's have one. What's this equal to? Oh, sorry,
Oh,
let me use this.
this
Remember what's this equal to?
wait,
It's a 6 factor. Then 6 minus 3 factor. Then 3's factor, right? Okay.
So it's, yeah, so we so value.
Mm.
Let's see.
Okay, that's all for this section. You can you can spend more time yourself.
Okay.
Okay, finally we wanna go to
Limits.
no, introduction to limits. This is the one of the most important concepts in
Calculus.
calculus. An introduction to limits. Limit notation looks like the limit as x approaches to infinity of x squared is infinity. Anyway, so LIM just the abbreviation of limit, right? Infinity. So see here, when x approaches to infinity, then 1 over x approaches to 0, right? Yeah, so we want to build this kind of concept. Then we call this x-axis is horizontal asymptote for this function, right? Mm. Some limit. By the way, yeah, so let's say this is an example. But before we see the example, do you have idea about what's the limit for this?
It's probably 0, I guess.
Huh?
Wait,
For example, part A.
oh, wait, it should be 7.
Here is x approach to infinity, not x approach to 0.
Okay, so then it's infinity. It's infinity.
Infinity.
Yeah.
Yeah, so normally when x approach to infinity, we just need to say the leading term, right? Mm. We can ignore this actually. Because for example, x3 compared with x squared is much, much greater, right? Mm. Or even you can say it's as greater as enough. Okay, then how about part B?
Part
How about
B.
its limit? When x go to infinity. How to judge this?
It says, wait, let me see. I think it's wait. So it's it approaches like the real zeros of the numerator.
Okay, yeah, normally people will do in
Yeah.
this way. So as x
Wait, actually,
approach to infinity, of course, x or x squared cannot be 0, right?
wait, I seen it approaches 2.
Yeah, approach
Yeah,
to
yeah,
2.
yeah. I just remember like the
Yeah,
formula.
yeah, but I will show how people do it. Limit. Oh, come on. Here's x approach to infinity. Yeah, we just both divide x squared, right?
Yeah.
Then here go to 2 minus 1 over x minus 7 over x squared. Here go to 1 minus 2 over x minus 15 over x, right? Yeah, so as x approach to infinity, compare with 2 and 1. This just like 0, like 0, like 0, like 0, right? It means approach to 0, not means it's really 0. So the limit go to 2.
Oh, okay, I see.
That being said, if it's not easy to observe the limit, you should do some algebraic conversion, right? finding horizontal asymptote. Yeah, so let's say this, take x squared, then so the limit go to 3. Yeah, so this is not so hard. You just find the limit of this first, right?
Mm-hmm.
Then plus 2. Okay. Then how to find the oblique asymptote? So do the division first, get this. Then find its limit. As the limit of this is 0. So what does this mean? Means this will approach to, yeah, I mean here, the g of x will approach to x minus 1 when x approach to infinity, right?
Mm-hmm.
Then this is a 9, so it becomes its oblique asymptote. Hyperbola. Yeah, anyway, you want some exponential limit. Okay, find the following limit. Yeah, this supposes something interesting. Especially part B. Cosine x always between -1 and 1. But when x approaches to infinity, 1 over x approaches to 0. Right?
Mm-hmm.
Yeah, anyway, from common sense, it's easy to know the limit will go to 0. Right?
Mm-hmm. Yeah.
Mm. Yeah, the limit approach to 0 means the value will be close to 0 as as close uh, as enough or as possible, right?
Mm-hmm.
As close as enough. Definition 1, limit equal to infinity. Let's say this, let f be a function defined on. Then the notation means that a given arbitrary large positive number and there is a sufficient large positive number m such that when x greater than m, f of x can greater than n. Definition. Yeah, anyway, so that means the limit just means the value will close to this, as close as enough, right?
Mm-hmm.
Mm. Or here use the words sufficiently, the difference is as small, um, as small as enough. Use the limit definition. Yeah, here like how to approve it's close enough, right?
Uh-huh.
don't exist. Using definition 1. Sin x just between -1 and 1 inclusive. Then is not equal to any infinity real number. Yeah, this is complicated, so we'll just skip it. Okay, let's just choose one. How about 17? How to find its limit? Or what is
Oh,
its limit?
let me see.
Maybe I can move this side on it. Yeah, you say
Oh,
problem 17 and 18, they are very similar, right? Just
mm-hmm.
one is opposite to infinity, another is negative infinity. Let's see if there are different answer. So I suppose you have two ways to find the limit, right?
Yeah.
One is you just both divide x, then you get limit x approach to infinity. So here go to x plus 10 minus 4 over x, right?
Mm-hmm.
And here go to 1 minus 2 over x, right?
Mm-hmm.
Then when x approach to infinity, this approach to 0. So it's go to like limit x approach to infinity, x plus 10. But as x approach to infinity, so this just go to infinity, right?
Mm-hmm.
Mm. Then similar thing, this should finally go to negative infinity, right?
Mm-hmm.
That's the difference. Okay, we'll stop here, and that's all for this pre-calculus course.
Mm-hmm. Okay.
Yeah, thank you for studying hard during these 7 weeks.
Mm-hmm.
Okay, let me close the